50 points. And last little section on this is function notation. So the rule for a function such as y equals x squared, so quadratic, we're going to often write it as what we say f of x. Now we've had a look at p of x, meaning a polynomial. This is a function, okay? F of x equals x squared. Means the same thing, it's just that f of x means f of x equals x squared. We also refer to y equals f of x. It's the same thing. They're basically the same thing, just two different ways of writing it out. So we say y equals f of x, particularly when graphing a function as the set of ordered pairs. So with x as the independent or explanatory variable and y as the dependent or response variable. F of x, we say, is the image of x under the function mapping, which means that if, for example, x equals 2, then f of 2 is the y value that x equals 2 is paired with, or mapped to according to the function rule. So when we look at y equals x squared, and we're using the point x equals 2, we're saying, what's our y value when we have 2 as the x? Okay, so it equals 4. Well, we do the same thing. So we're saying when f of 2, so instead of x we're having 2, we do the same thing. It's 2 squared, we get 4. And we've used p of x notation for polynomial functions. So f of x equals x squared. As I said, f of 2 equals 2 squared equals 4. So we're saying whenever we see x, we're putting 2. So we're replacing x in the function for 2. Ordered pairs that form the function with rule f of x equals x squared could be illustrated on a mapping diagram. So mapping diagram, okay, got a diagram here. We've got f of x equals x squared. And we can relate every point. So 0 under x squared goes to 0. Minus 1, well, that becomes positive 1. 1 squared is 1. 2 squared is going to be 4, and so on. So we also get minus 2 squared is going to be 4. So that's a mapping diagram. Now our ordered pairs is going to be 2, 4, and minus 2, 4. Here we're going to have 1, 1. Here is 0, 0. We also have minus 1, 1 there as well. So the ordered pairs that form the function with rule f of x equals x squared could be illustrated with the mapping diagram. The mapping diagram shows the uses uses 2 number lines for the x values and 1 for the y values. But there are varied ways to show mapping diagrams. Under the mapping, every x value in the domain is mapped into its square. So every one on here we map onto its squared value. The range is the set of images or corresponding y values of each x value in that domain. For this example, the polynomial has a domain of R and a range of 0 to infinity, because every time we get negative numbers down here, we're going to have positive numbers on our mapping. So we're going to go from 0 upwards. Doesn't matter what number down here, always gets squared, so we're going to have a positive number. So we've got R as our domain, and our range is going to be from 0 to positive infinity. Just a note on square brackets. Square brackets means it includes that number that we have there. So that's like less than and equal to, or greater than and equal to, includes that point. Whereas open bracket means it's up to that point but not including it. And infinity we always write as a open bracket or a curved bracket, because we can never actually reach infinity. We get very close, but it is a concept and we get closer and closer without actually touching it. Not all of the real numbers on the y number line are elements of the range in this example. So formal mapping notation. The mapping of x to x squared is formally written as followed. So x to x squared we write as f, meaning the name of the function. R is our domain. The domain of f. And we have this arrow and R, which is what we call the codomain. So, the set of all available y values, whether used in the mapping or not, is called the codomain. So here, the set of all available y values. So it's all available y values in this case, whether we use them or not, is going to be what's called our codomain. So that's our codomain. Is going to be all these numbers on here, whether we used them or not. However, the range is just the numbers that we use. So it's just from 0 to infinity. Whereas a codomain is going not the range. So we don't look at domain and range, it's domain and codomain. Whether we use them or not is our codomain. So the domain of the function must always be specified when writing functions formally. We will always use R as the codomain. Mappings will be written as f of d to R, where d is the domain. Usually a graph of the function is required in order to determine its range. I'll finish off with this example. So consider f . So we've got f, our domain is R, our codomain is all real values, and f of x is a plus bx. We know f of 1 is 4, f of minus 1 is 6. So part A, calculate the values of a and b and state the function rule. Well, we know f of 1 is 4, so let's use that. So we say f of 1 equals 4, therefore we replace our y values, I guess. For 4, our x values are going to be 1. So we say 4 equals a plus b. Now, same thing for this one. F of minus 1 equals 6. So we can say 6 is a plus b times minus 1. So 6 equals a take b. So equation 1, equation 2, simultaneous equations. Let's go 1 plus 2. 4 plus 6 equals a plus a, b plus minus b. So we get 10, these two cancel, equals 2a, a equals 5, and now we can solve for b. So we'll put it into 1,